Assalamu alaikum. This is 12th chemistry, and our topic is Brownian moment and this Tyndall effect. As you know that we're discussing these colloidal solids. Now, as far as their properties are concerned, Brownian moment, it is one of their mechanical properties, uh, and uh, and it was Robert Brown in 1827. He observed that when pollen grains are suspended in water, they exhibit a sort of a kind of this zigzag moments. And later on, it was observed that when a colloidal solution is examined carefully under an ultra microscope, the particles of the this dispersal phase, they exhibit the same kind of moments, and this ceaseless random and zigzag moments of these colloidal particles, it was termed as Brownian moments. Now, as far as these Brownian moments are concerned, the explanation to these Brownian moments, it was provided by kinetic molecular theory of liquids, which assumes that the molecules of the dispersion phase, they are always in a state of constant and random motion and irregular motion. As a result of these irregular, random and constant motions of these molecules of the of the dispersion medium, the colloidal particles, colloidal particles, or the molecules of the dispersal phase, are unequally being bombarded from all sides by the molecules of the dispersion medium, and as a result of which they move in that direction of the resultant. Now that means these colloidal particles, and they keep on changing their directions as a result of unequal hits from the molecules of the dispersion medium. Now, greater the number of these unequal hits from the molecules of dispersion medium, greater will be the extent of these Brownian moments. Now, it was then observed that with the increase in the size of the colloidal particles, or with the increase in size of the sol particles, the Brownian moment, the Brownian moment decreases, and it ultimately vanishes when the size of the particles becomes equal to the size of the particles of the coarse suspension, because at this stage the force of gravity begins to act, and these particles, they settle towards the bottom of that container. So in case of these suspensions where the particle size is very large, these Brownian moments, they are either or absent, or they are or negligible, because the particles now begin to settle down under the action of gravity. Now, this Brownian moment, to a greater it is this Brownian moment, to a greater extent, is responsible for the stability of these colloidal solids. So this is a mechanical property of these colloidal solids. Similarly, we have got diffusion, we have got this sedimentation. Now, as far as the optical properties of these colloidal solids are concerned, we have got Tyndall effect. Now, as far as this Tyndall effect is concerned, it was observed by John Tyndall that when a beam of light is passed through a colloidal sol placed in a beaker in a dark room, path of this beam, the path of the beam becomes illuminated with a blue light when it is observed through a microscope placed at right angles to the path of the beam. Now it is seen that these colloidal particles, they look like pinpoints of light when observed under microscope, moving against the dark background in the colloidal solution. Now, as far as this Tyndall effect is concerned, this Tyndall effect, scattering of uh, it is due to the scattering of light by these colloidal particles. Now, the cause of this Tyndall effect, or the cause of this phenomena, is due to the fact then when light is passed through a colloidal sol, these colloidal particles, or the colloidal particle absorbs a part of this light, and it then becomes self-luminous, and then it becomes self-luminous and looks like pinhead, and it then scatters a part of this absorbed light. Now this scattered light, corresponds to the wavelength of the blue blue color, and thus the path of the beam, or this path of this light, it becomes visible with blue, with a blue light, or with a blue color. Now, if the same light is passed now through a true solution, placed in a beaker in a dark room, this Tyndall effect, it is not observed. The reason being that the particles of a true solution, that is the particles of solute in a true solution, they are too small to scatter this light. Now, so this Tyndall effect is observed in case of these colloidal solids, and it is not observed in case of a true solution. Now, another property of these colloidal solids is that they have got that is protective action. Now, protective action. We know that these lyophilic colloids, they are very much stable as compared to lyophobic solids, or lyophobic colloids. Now, the reason behind the stability of these lyophilic colloids is that the particles of the dispersed phase, in case of these in case of lyophilic solids, that there is extensive solvation of these of sol particles by the molecules of the dispersion medium. So because of this extensive solvation of these sol particles, or these lyophilic solids, they are much more stable as compared to lyophobic solids. Now, these colloids, or lyophilic solids, they exhibit a property, or they show a property of protecting lyophobic solids from electrolytes, which cause their immediate coagulation or precipitation. The protective action of these lyophilic solids is due to the fact that these lyophilic solids, they form an envelope, or they surround the sol particles, surround the particles of the dispersed phase of these lyophobik solids, and protect them from these electrolytes, which cause their immediate this precipitation, or which cause their immediate coagulation. Now the different substances we have got, the different substances like this gelatin, we have got this gum, they are used, or they have got a protective action, so they are used as protective colloids. Now, the addition of gelatin to a gold sol, prevents it from coagulation, or from precipitation, by the addition of an electrolyte like NaCl. Now, different these lyophilic colloids, they have got different these protective powers. Now that now the protective power of these lyophilic colloids it is measured in terms of a gold. It is measured in terms of gold number. Now this gold number it can be stated as it is the minimum quantity of this lyophilic sol or lyophilic colloid, which must be which is sufficient which is sufficient to prevent the coagulation, which is sufficient to prevent the coagulation of 10 ml of standard red gold sol by the addition of 1 ml of 10% NaCl. That is that is electrolyte. So we see greater, smaller this gold number of this lyophilic sol, greater will be its protective action. So this is for this this for today. And today we have discussed this Brownian moment, which is one of the mechanical properties of these colloidal solids. Then we have got this Tyndall effect, that is the optical property of these colloidal solids. Then I have told you the this protective action of these lyophilic solids, and which prevent these lyophobic solvents and lyophobic solids from the coagulation or from precipitation. This is for today. Thank you very much.